Hello everyone. In this lecture we are going to learn about types of stress analysis in piping domain. Our flagship courses are Master Static Equipment Design and PVE Light, ASME Section 8 Division 2, and Master Welded Storage Tank, as per API 650. We have curated courses to suit your learning needs. So do visit our learning platform for more details on scutoid.thinkific.com.
Stress analysis is the highway for the design, I would describe it as. Why? Because in a plant, for example, many of you are already working in design of a plant, either on the plant or in some design office. So you may be knowing that, for example, a refinery, if you take, what is the number of pipes in a refinery or whatever plant that you are working on in one single plant, 10,000, 1,000, and a refinery may run up to 5,000 and plus also. Yeah, very good. Yes. Now, why stress analysis is required is many of these lines, out of these 1,000 lines or 10,000 lines, they will need special attention in designing, and how to identify those lines and how to design those lines is taken care by the group which is handling the stress analysis. Because if a plant contains some 10,000 lines or odd numbers, such as thousands of numbers, you need not give the entire attention to all the 10,000 lines. Some piping will need a higher amount of attention in design. Some piping will need a moderate, and some piping will need a low amount of design attention. So this particular group, stress analysis group, yes, it identifies the lines which are required to be designed for a very high importance. So the basic loads, what could be the basic loads for design? This is going to be pressure and temperature, which are going to be the basic loads. Whenever there is any system which needs to be checked for designs, first thing what we do is we find out what is the pressure and temperature. Now in pipe stress analysis, you will find that pressure does not play much part, which is different from your static vessel designs, where static vessel designs, pressure will play a very important role. But whereas in pipe stress analysis, pressure plays a very non-significant role, because most of the piping which is covered in the industrial area or in the refineries, etc., they are going to be at moderate temperature, moderate pressure. Only very few lines are expected to be at pressures which are, say, beyond 75 bar or more than 75 bar. So only in such cases there is going to be some effect of this pressure on the flexibility of the piping. Otherwise, the pressure does not play much important role in the analysis. So our main loading which is going to be there is going to be the temperature for the analysis of pipelines. Wind seismic. Now, snow is generally not applicable in Indian continents or in Gulf areas or something. But yes, whenever you are, and then wind and seismic, as well as the blast case or the snow case, comes under occasional loading of the piping. And lastly, some process mishaps. What are the effects of some process going out of control? Any direct mishap that you can see? Yeah, PSV reaction process, right? So that means a blowout of a PSV. Whenever a PSV blows up, you are going to experience some reaction in that zone, and then we need to take care of this. So our focus for today is going to be these three types of loads: basic loads, occasional loads, and the process mishap loads. So, for example, the pressure relief valve. So what you see here is the flow is from inlet to outlet, and then there is a reaction which is developed at the junction of inlet and outlet. And why this reaction is developed? Any reason why this? Why do you experience this reaction here? Why at this point only? So what happens is there is a change in the form of energy from inlet to outlet. When in inlet, you know that there is high pressure and low velocity, and once it is released, it is exactly reverse. It is low pressure and high velocity. So there is a change in the form of energy from inlet to outlet, which leads to a reaction at the junction of inlet and outlet. And this reaction is going to be in two directions, that goes into the detail. When we go into the detail, that time we'll see. Now let us see types of analysis. So let us see what are the different types of analysis here that are carried out in normal industrial projects. Number one, static thermal analysis. Yeah, very good, static analysis. Now this every word has got some meaning. So static means it is the line has reached a temperature and it stays at that temperature for a longer duration. That is what we mean by static. It is not a case where the line achieves a temperature for a fraction of a moment and then it is immediately withdrawn. So that is not the case that we are defining here. We are designing the pipes where the pipe attains some temperature and it stays at that temperature for the cycle of operation of that particular pipeline. So that is called as static. And thermal, yes, we know that it is temperature. And when we are talking of temperature, it is the cyclic temperature. There is always going to be a cycle of temperature for each pipeline. So a very simple case is, okay, maintenance, but okay, okay. Weather, yeah, maybe a little bit, yes. Yeah, weather is also true, but in extreme cases, yes. For example, in Gulf countries or something where the night temperature and the day temperatures are very much different. So that time it may come. But in normal case, in operations case, what happens is for a very simple case of one pump working, one standby. Normally, the process lines will have the suction will be such that there is going to be a one pump working and another on standby, and after some time, the pumps are going to be reversed. So what happens is in operation, what is going to be done is the isolation wall at one pump suction will be closed, and that pump will be under maintenance, and the other pump is working. Yeah, and then after some time, whenever as per the requirements of the operations or the maintenance are required, the pumps are reversed. So the first pump will go into operation, second pump will go into the maintenance. So this kind of temperature change will occur for this pipeline over a certain period of time, maybe 15 days, 1 month, or whatever is that defined philosophy for that particular system. So similar will be applicable for discharge also. So these are called as the cycles of temperature. Now, in some cases, this is a very simple case where the cycles of operations are some few days or some months. In case of some lines where the lines are going to be continuously operating over the year, for maintenance, when the plant goes down for shutdown for maintenance, then once in a year at least, maybe some 10, 15 days or so, the pipeline is going to be shut. So that is so the frequency of the cycle may change, but every pipeline is supposed to be undergoing a change in the temperature. Okay, next is dynamic. So seismic analysis, natural frequency analysis fall into this category of dynamic analysis. Normally, this dynamic analysis is done for very critical piping, such as nuclear power plants, where the acceleration due to the seismic activity is high, and the fluids which are handled are very much dangerous in nature. So radioactive materials are involved in such plants, and then you need to do the dynamic analysis. So here the load changes with respect to time. So there is an acceleration in the loading. So such cases are identified or analyzed with the help of dynamic analysis, time history analysis. Then we have surge analysis. Surge, what is meant by surge? Sudden change in pressure. This may be due to some operational philosophies. For example, sudden shutting down of a wall. Very good. Yes, sudden closure of a wall is one of the reasons of developing this pump on off. Very good. Or check wall, slamming of check wall due to some reverse of flow. So this all leads to surge. Now this is pertaining to only water, and why it is different from the first one is water pipelines are normally of a very big size. You know that there may be something like 1 meter, 1.5 meter, 2 meter diameter. Yeah, we will come to that sludge analysis. Yes, we'll come to that next. Water analysis is similar to surge analysis, except that it is water and very large network is there and very large diameter of piping is involved in this. Then acoustic analysis. Acoustic analysis is for high velocity gas piping transportation. So where you expect a lot of noising, hissing, and then when you want to curb that, we go for acoustic analysis. And then sludge analysis, somebody was talking about sludge analysis. So sludge analysis is occurring in case where you have a two-phase flow, two-phase or three-phase flow whenever it is involved. It is called as sludge analysis. Here, for example, a liquid is mixed with some solid materials which flows with the velocity of the liquid, and then it goes and impinges on every bend. For example, at every bend, the solids will go and hit, and it will create some force on that, apply some force on the bend. And at every bend, it is going to do the same activity. So you need to calculate the forces, apply those forces, and analyze the system. So that is called as sludge analysis, which is applicable for two-phase or three-phase flows. And finally, it is the vibration analysis. So whenever we are large diameter piping for compressors, then turbines, then pumps, which are of very large diameter, there we go for vibration analysis. Now, out of this analysis, the one that we are concentrating on is going to be only static thermal analysis. And why? Is because it caters to the almost 90 to 95% of the requirement of the industry. The static thermal analysis takes care of almost 90 to 95% of the requirements, and all the other analysis are only specific to some few lines in plant or in any application. So what we are discussing, the topic of static thermal analysis is going to help you in almost solving 90 to 95% of the cases and analysis requirements in a design of a plant.
Launching of online live sessions on pipe stress analysis and caeser, 2 course.
Okay, so in this entire course, we are going to see the basic theory for the stresses which are going to be generated because of this, understanding the expansion, the strain, the expansion loads, then what are the types of different loads other than the expansion, like occasional loads, which are going to be affecting the entire analysis of the piping system. And then we will see what are the theories of stresses which are defined by the code. And then we will also understand what are the different types of stresses which we have to adhere to and make it acceptable to the code, which are not generally not seen as part of the other components. For coming to the piping, it is a particular different type of stresses which are going to be seen, and then the code asks us to calculate that amount of stress, and then it allows us to limit it to some values. So we will understand from that theory how to calculate those stresses and limit those different types of stresses to the values given by the code. Then we are going to see the code requirements, the piping code references, the code compliances. What does the code say about the requirements of meeting the stresses, highest stresses values? Then we will study the theories of failure. We will also understand the complex stresses in terms of the secondary stresses which are generated due to temperature, and the concept of the stress intensification factor, which is going to be a more important from the point of view of the analysis and how it affects the entire analysis. Then we will also study what are the different solutions. So once we understand what are the problems which are there in the system from generation of or passing of the temperature, then finding out the problems and then attacking those problems to resolve and meet the code requirements. So we apply different techniques like enhancing flexibility, adding the expansion loops, then play with the friction along the pipe supports, use of springs, bellows, etc. So and then understanding the equipments. So static and rotary equipment, they have to take the loads from the critical piping system when we analyze, and they also play an important role in meeting the requirements of the code, because the stress analysis, once it is done, it's not only that the piping will be required to be meeting the requirements, but the connected equipment, the connected structure also needs to be satisfying and meeting the requirements of the entire system, so that the entire system remains safe. It is not only piping which needs to be safe, the connected equipment, the connected supports, on which the piping is resting, that also needs to be safe, and the code places the onus on the stress analyst for this purpose. Then we are going to see the other types of loadings, which are in the form of wind, seismic, the PSV reactions, and there are some more reactions also, like a snow blast, etc., which will be there, and we will just study those reactions in the piping systems. Then we will see the entire understanding of the supports. So what is the requirement of the supports from the point of view of code? Then various types of supports from the construction, various supports, how to take the supports from the equipment, the functional types of supports, which are in the form of resting, guide, axial stop, anchor, fixed point, etc. Then use of spring supports, which are other than those rigid. So far, we talked about rigid supports. Now, these are the flexible supports like spring supports, and then understanding what are the different types of spring supports and selection of the springs from the vendor catalog, which is an important part. Although the code, the software also finds out, but then we must know and we must be able to play with the selection of the springs from our understanding of the vendors' offers that we have. Then we'll study the entire caeser 2 software, that is in the form of what is the data collection which is required for caeser, then overall the views, overall functions which are provided by the caeser 2, and then we'll go from the basic modeling requirements, then piping modeling, equipment modeling, the built-in database which is available, restraint modeling, and then we will add one by one as the cases are there, the seismic requirements, the wind requirements, PSV forces, if there are some initial displacements from the connected equipment, that also will be done. Then we will study what is the how to calculate a loop on a pipe rack, and different types of loops, 4D, 4 band, 6 band, etc. And then we will continue with detailed problem solving with the help of what are the different facilities available in the caeser for ease of modeling. And then we'll apply the technique to find out various systems which are subjected to a temperature pressure variation. Many systems will operate in such a way that in one cycle they will some part of the piping is going to be hot, another part is going to be cold. After some time, the previous part which is hot will be cold, and the earlier which was cold, which is going to be hot. So how to analyze such systems, and such cases may be two, three, four different types of operating conditions will be there. So here we need to understand how the operation of the entire system is going to be there, and we must apply all those operational requirements to the system, so that we will understand the analysis of each of operation. Then in this particular thing, we are also adding some super advanced requirements, such as modeling of the spring supports, modeling of the bellows, then flange failure checks. We were talking earlier about flange. When sometimes if the stresses are very high, then the flanges may also fail. So how to check the flange, this thing. Then initial displacements, how to impart initial displacements, how to impart nozzle flexibility, because equipment is having a nozzle, and that nozzle is also having some flexibility. So how to take advantage of flexibility of the nozzles which are mounted on the equipment. Then how to check the nozzle loading limit checks supporting from the equipment, and some dynamic understanding of the analysis, like natural frequency calculation, slug and plug possibility, two-phase flow. And then piping subjected to dynamic seismic response spectrum method. So all these very high super advanced courses, which are normally not included in other courses which are available in the market, that also we are going to cover in this particular session. So it is going to be really a useful tool for everybody, and it's going to be a giant jump in the form of your career in your life.
Now, let me just tell you more about the course. So this syllabus has been already been discussed. We are going to cover a content which is from basic to super advanced level, theory, examples, and we are also going to cover software part, that is caeser 2. So these are going to be online live sessions. The way we are conducting this webinar, this is live. Similarly, these are going to be online live sessions. whatever syllabus has been discussed by Sudhir sir, to cover those syllabus, it will take around 55 to 60 hours. That will be spread in 5 to 6 months. The first class we are going to start on 3rd June, and the timing is going to be the same, 8:30 p.m. and we are going to fix the weekdays, Tuesdays and Thursdays. So this classes will happen on every Tuesday, every Thursday, sharp at 8:30 p.m. Each session will be of 1 or 1.5 hours. And as I was saying, there is total content of 60 hours, which is spread in 5 to 6 months. Upon the live sessions, you will also get a recording, because we also understand that since it is on a Tuesdays and Thursday, there might be a chance that you might miss out a couple of lectures. So to help you out, so that you cope up with the online sessions, the recordings will be shared with you. You can go through the recordings, you can use the recordings. If you have missed out anything, you can use the recordings for the revision purpose. But the recordings of each and every session will be shared on our learning platform. And this, on the learning platform, you will also have test. There will be material which will be available. And the access to the e-learning will remain for another 1 year after the course is completed. So that means for the 5 to 6 months, you will already have a access to the e-learning platform. But even after the course completion for another 1 year, the e-learning access will be available for you for the revision purpose. And very important, you will also have a support of Q&A sessions. So when we are having a live session, of course, during the session also you will have a Q&A session. But even after completing your course after 5 to 6 months, you will have another support of Q&A session for another 1 year. And as we do it for the static courses, here also there is a WhatsApp community which will be available for the discussion purpose. So after the course completion, depending on the performance of your test, a certificate will be issued to you, which will have a grading system.
To learn more about the piping course, fill out the Learn More form in the description below.